velocity and distance in two dimensions. Here we are given a problem about a ball that travels at a velocity of 1.5 meters per second at an angle 23 degrees above the x-axis. So as you can see, I've already drawn out a picture of this and also listed some given information. We've also know that the total time that the ball travels is 7 seconds. What we're actually trying to find in this problem is the distance that the ball travels using the x and y components. So the first step that we need to take is to find the velocity of the ball and its x and y components. So an easy way to think about that is to kind of break the velocity up into basically its two components, and it should make a right triangle. So it should look something like this. Here you have your velocity, and you can break it into the x component, and here you can actually break it up into its y component. And now we still know our angle in there. We know that that is 23 degrees. So we'll just have to do a little bit of trig to actually find the velocity in the x and y directions. So the velocity in the x direction should be equal to the total velocity multiplied the cosine of the angle that we have. So if we substitute our information in for that, our total velocity is 1.5 meters per second, and our angle is 23 degrees. So if you calculate that, our velocity in our x direction should be about 1.38 meters per second. Now we can do a similar thing for the velocity in the y direction, except this time it should be the velocity multiplied by the sine of theta. So again, we'll substitute our information in, and when we do that, we come up with a velocity in the y direction of 0.59 meters per second. So now that we have our velocities in our x and y direction, we need to actually find the distance in each direction. So we can use a pretty simple formula that is usually used for rates, which that is distance is equal to the rate multiplied by the time. So to find the distance in the x direction, we'll just multiply by the velocity in the x direction multiplied by time. So we'll substitute in our information for that, and we should get the distance in the x direction to be 9.67 meters. Now we'll do the same thing for the distance in the y direction, which should be equal to the velocity in the y direction multiplied by time. Substitute that information and calculate that, and that should come out to be about 4.10 meters. Now we have our distance in our x and y direction, but now we need to find our total distance. So again, if you want to draw a picture, it might help you out. There's our total distance, but we know we've gone 9.67 meters in the x direction and 4.10 meters in the y direction. And if you notice, this should actually make a right triangle because we are separating them into x and y components. So you might think, well, how do you solve for d? You can simply just use the Pythagorean theorem here, and it should be d squared is equal to 9.67 meters squared plus 4.10 meters squared. Now if you take the square root of both sides of that, you should actually get the total to come out to be 10.5 meters. And that's a problem using velocity and distance in 2 dimensions.